So now that you learn gradient descent, we have to apply this to linear regression. So once again, this is the sum of squared errors. Sorry, the loss function that we're using is the mean squared error. It's this one, right? That is what we're trying to optimize. And we do some derivation again. I'll just give you the slide deck if you want to check how to derive it. But we want to compute for the derivative. Again, that's one component of gradient descent. So it's that. This is that. Computing for the gradients. Yeah, all the shenanigans, and then you will end up with this. So this is the equation that you have to use for you to get the updated value of your theta. Theta is the weights. So that's one term that we use in machine learning, weights. Or the M, or the slope, whatever you want to call it. But it's weights or theta. So you multiply the weights to X. X is your input. So X input times the weights equals output. So we're trying to figure out the best value for the weights or theta. And it's this one. Yeah, it is simply this. This is your equation. Theta is equal to theta minus learning rate over n times, n is the number of samples, times x theta minus y transpose x. So it's still the general gradient descent equation. We just replaced this one with, of course, the gradient equation, the derivative of the function that we're using. So the derivative of the mean squared error. Okay. This one. That's what we're trying to optimize. Still following? So these are the equations that you have to take note of to be able to implement linear regression. Just the following ones. So the loss function, the gradient function, so the gradient of this loss function, it's this one, and the weight update. These three equations. That's all you need to remember. Okay. Following so far? Following. So the weight update contains the gradient. It's this one, this part here. Just replaced it with the gradient function. So why do I still have the loss function? Again, what is your criterion for stopping the loop? I would have to go back. Sorry, it's the updated gradient descent algorithm in the context of linear regression. So yeah, you initialize the starting weights randomly, up to you. But I'm going to provide you a template for this one, so don't worry about it. And then while it's still not converging, so it says the change in loss is too small. So that's why I still have the loss equation here, because that's how you determine if there is little to no change now. So after that, you compute the prediction x theta, compute loss given x theta and y, then compute the gradient and update the weights given the gradient and learning rate. Still the same gradient descent algorithm, but I have replaced the variables with the ones that we're using for linear regression. Looks. Can you still follow, guys? Thumbs up. Yeah. Of course, I'll be giving you all the resources. So I know that you guys may need more time to fully absorb this. So that's okay. That's okay. Don't expect you to understand everything in one go. Don't worry about it. Okay,